In this video, we're going to introduce an example of error, mean squared error. As a reminder for what error is the amount of numerical difference between two pieces of data that are being compared. This has many applications in AI, including classification and prediction, which we'll get into in this video. But first, let's look at what mean squared error actually means. Over here is the formula for mean squared error. Essentially, what it's doing is for each value between two pieces of data, in this case A and B, we get the difference between those values, square it, and then add all of these squared values together, which is signified by the summation value here. After we add all those together, then we're dividing by n, which is the number of observations in the data. Let's write this out with this example of the data that we have here. First, we get the difference between B and A. We do this by looking at each of the pairs of values for B and A and subtracting them from each other. Once we do that, we square all of these differences together, and then we add all of these together. So as you can see, we're adding 1, 4, 9, and 1 together because these are the squared differences. Once we have the total, which is 15, we divide it by 4 because that is the number of observations that we have over here. This gives us a mean squared value of 3.75. So what does 3.75 mean? Or in other words, what does mean squared error mean? Mean squared error is a way for us to measure the distance or difference between two groups of data. Let's look at another example of when the data is similar and see what happens to the mean squared error. In this case, I've changed the values of B to be a little bit closer to that of A. Again, we can calculate the difference between B and A, square those, sum it together, and then finally divide it by the number of observations that we have, which is 4. Here we get a mean squared error of 0.5. This tells us that the more similar the values are, the lower the mean squared error is, because we're literally calculating the difference between the values of two groups of data. Let's look at some examples of mean squared error in AI. First, let's look at classification. Classification is when we group an unknown object in a certain class. For example, we can use mean squared error to calculate if a random person is an athlete given certain characteristics. In this example, we first gathered information about an average athlete, seen over here, such as minutes per mile, calories per day, and resting BPM. We can compare these with random people, like this one and this person here, to determine whether or not they are an athlete. This is where mean squared error comes in. I won't calculate it in this example, but you should find that the mean squared error of the first person is much higher than the mean squared error of the second person. The low mean squared error of the second random person suggests that they can be classified as an athlete, whereas the high mean squared error of the first person suggests that they might not be an athlete. This is one example of classification, and in the lesson that you'll be teaching the students, we'll be doing classification for characteristics of a face. Another example of mean squared error is in prediction. You might remember that we used a line of best fit model to predict values. We can actually use mean squared error to measure the accuracy of a line of best fit model. Let's look at an example to see what I mean. We'll be looking at how many items we will sell given the number of customers in the store. The goal is to try to be able to accurately predict the number of items sold given the number of customers. First, we start with actual values. Then, given the actual values, we can guess a line of best fit. Once you have the line of best fit, we can use this to create a new set of predicted values. The predicted values are calculated by using the line of best fit by inputting the input value of the actual value, in this case X, which is the number of customers, and using the formula of the line of best fit to output a predicted Y, which is our predicted number of items sold. Now that we have the actual values and the predicted values, we can compare the actual and predicted values to get the mean squared error. What this actually means is that we're looking at the distance between the actual value and the predicted value, and using that to see how close we're able to get to the actual values. In this sense, we're calculating the accuracy of the line of best fit model. This distance is called the error. Before we do this, let's first gather our points and put them on a table. You can pause this video to understand how we translated these points into a table of values of actual values and predicted values, which we got again from our line of best fits. Now that we have these numbers written down, we can get into the formula of a mean squared error. The mean squared error is calculated by getting the difference between the predicted value and the actual value. We'll be using this as an example to show how it works. First, we start with getting the difference between the predicted value and the actual value, just by using subtraction. So here we've calculated the difference. Once we do that, we can get the square root of the difference. If you're wondering why we calculate the square of the difference, you can check the questions that I put in the knowledge resources after this video. Once we get the square root of these differences, we can add them all up, which is signified by the summation. So adding up all the values over here to get 2.4. Finally, once we have all of that, we can divide this by the number of observations that we have, which in this case is 5 total observations. This gives us a mean squared error of 0.48. Great, so we've calculated a mean squared error for this line of best fit model for our prediction for how to calculate the number of items sold given the number of customers in the store. So what does this value mean? Is 0.48 a relatively good mean squared error or a bad mean squared error? To put this into perspective, let's look at if we had a different line of best fit for the same example. Let's say we had this line of best fit, which is much steeper. We can predict values just like we did before by marking new data points, and we would be able to calculate the mean squared error in the same way by getting the distance between the predicted value and the actual value. So I won't calculate the mean squared error, but think about if the mean squared error would be larger or less than the mean squared error that we had in our previous line of best fit, and what this tells us about which one gives better accuracy for predicting the number of items sold. Remember that the less error a model has, the more likely it is to give accurate predictions. So that was an example of how we can measure the mean squared error of a line of best fit model. And hopefully this explains a little bit more about how we use error to measure the success of a mathematical model in AI.